Hello, and thank you for joining us from wherever you are in the world for today's Aviation IoT special. Before we get going, I want to tell you all about a major AI event that's taking place in England next month at the historic Bletchley Park in Milton Keynes. The event is called the TechWorks AI Launch Pad, and it takes place on Tuesday, the 16th of April. Any and all details for this special day, including the agenda and speakers, are available via techworks.org.uk/AI. And for those watching today's broadcast live, in a few moments, I'll put the link in the Zoom chat facility where you can see all of the details for that. So coming up in this hour-long aviation special, we'll have Lee Speakman from the University of Salford. But first up is Ken Munro, and he is founder and CEO of Pentest Partners. He is in a field near Buckingham in England. Ken has been working in IT security for over 15 years. He writes for various newspapers, I should say, and industry magazines, and is a regular source of comment and sanity on IoT issues to various news agencies and the BBC. The title of Ken's presentation today is Dude, Where's My Plane? Ken, the floor is yours.
Great, thank you very much. Hopefully everyone can hear me okay. But here's commitment, all right? I've even got a British Airways office seat. That's one of the ones recovered from a refurb recently. There you go. Anyway, right, I want to talk a bit about aviation. A little bit less about IoT, a little bit more about some of its implementations in the air. So my background, what am I? So before I stumbled my way into cyber, I was actually trying to be a commercial pilot. And over the last 20 years or so, bizarrely, my two loves have come together. And I found myself working in aviation cyber, very new field. Who am I? What am I? I work for a firm called Pentest Partners, about 150 of us in the field in North Bucks and in New Jersey in the USA. Randomly, we've got quite a few pilots on the team, both commercial, both wannabe commercial like me, and also private pilots as well. And over the last few years, we've done quite a bit of vanilla research into many of the systems you'll find on board planes and on the ground that guide planes as well. Now, first things first is we are responsible and ethical. It's actually incredibly difficult to fix a vulnerability on a plane, not because it's hard to fix the code, but because it takes a long time to recertify that code to make sure it's not going to cause a blue screen of death when you apply that update. It's one thing losing a PC on the ground, losing a flight control system in the air is kind of a bad thing. So it takes a long time to fix stuff. So 90-day disclosure, you'll see with Google Project Zero, doesn't really work. And some of the vulnerabilities we've published and given to manufacturers to fix have taken nearly 2 years between disclosure and us going public about them, because that's just how long it takes. The media also seems to lose their shit when it comes to plane hacking stories. So often they misunderstand, and you'll see a lot of sensation, which really obfuscates the truth of it, that planes are incredibly difficult to hack. And no, you can't hack a plane from your seat back in economy. What's changed? What changed for us? Biggest obstacle to any sort of airplane cybersecurity research is kit. It's all expensive, it's certified, even a simple piece of avionics equipment can cost you 6 figures. Very rarely comes up on eBay. When it does, it's old and out of date. However, there was a silver lining of sorts to the COVID pandemic. A lot of aeroplanes that were perfectly serviceable got laid up. The breakers yards got backed up. They, instead of having 5 planes in, they had 50. So we took an opportunity, gave one of them a call, said, look, if we pay you for the Jet A1 to run the power units, can we come and learn how to hack the plane? They were like, well, it's never going to fly again. There's no risk to it. We could do with the money. Yeah, all right. So we had carte blanche. We had our choice of, I think, 6 747s to play with, and a stack of Airbus A320s. So loads and loads of opportunity to do something new that had never been done before. We did learn that there's very high voltages on board airplanes that hurt. I have to be very careful. As you can see, my colleague there is the clever one. I'm just holding probes into things to analyze the various flight control networks protocols, see how they work. It's expensive to access and decode, even more expensive to inject traffic onto a flight control network as well. But we are starting to see components become a bit more available now, so that's a good start. So what about the connectivity? What about the connectivity in a plane? So There is an increasing amount. It used to be you had VHF radios and not very much more. Increasingly now, we're starting to see connectivity for passengers, for efficiency, for routing, avoiding headwinds. We're also seeing data feeds for loading software updates, so the quick access recorders, the data loaders, the flight management systems. But the good news is for us as traveling public is they are all really well segregated. So there's excellent segregation between the dirty bit in the back where we as passengers sit and the safe and secure bit up front where the pilots control the plane. They are very distinct flight domains. So you've got the aircraft control domain, or ACD, up front. And at the back, you've got the passenger information and entertainment services domain, or PIESD, and they are completely isolated. Back in the day, you used to see a one-way data feed with a data diode going from the flight management system back to the moving map so you could see where you were, and now typically they're separate feeds. So they are very well isolated. But what can go wrong? Why are we bothered about this? Why are we concerned about aviation cyber? Well, stuff happens already. There's been a few interesting stories. So Raven Air, operator in the US, their entire flight maintenance system was ransomware together with the backup. So they lost the ability to prove their planes were airworthy. And if you can't prove they're airworthy, you don't go. That pretty much tipped them over into bankruptcy, although I believe they've risen like a phoenix from the ashes since. But it makes you realize that it's not just the planes that need to be kept secure, it's the systems that are interfacing with them too. You might remember this one. This was a really interesting outage. So American Airlines lost their electronic flight bags. I think they were using a Jeppesen charting system to do the maps of how you approach an airport. And there was a duplication. So Washington Reagan National Airport, I believe, had a duplicate entry, and that caused the flight bags to lock up. And because we don't carry paper anymore, those planes didn't go that day. So that caused all sorts of problems. Another random one. So this is a weather outage. Now, you might think you could look out the window of the cockpit and go, yeah, it's all right. But planes need to know what the weather's like aloft and also at their destination. They do that using electronic weather feeds. So that failed on a Southwest day, and over 1,400 planes didn't move that day because they didn't know what the weather was doing. There are breaches that happen left, right, and centre. And also a really interesting one. In the US, a lot of the airports are owned by the city authorities. And I think it was the city of Atlanta had a ransomware outbreak and actually turned off the passenger Wi-Fi in their airports to prevent any sort of propagation, which was a nightmare. Another random one. So this is a really important vulnerability. This is a load sheet application that runs on the flight bag. It basically tells you where to load the passengers, where to load the fuel, whether you're in or out of the center of gravity limits. And that's really important because if you're too nose heavy, you don't take off. You're too tail heavy, you run the risk of stalling. And this is an incident that's been published. You can go and read up about it. And what happened was that the plane type was changed from an Airbus A320 to a 321, but the load sheet wasn't updated properly. And as a result, all the passengers were loaded for the shorter plane, so at the front, which meant that the plane was out of limits with forward center of gravity. The pilot piles off down the runway, thinking he's in balance, rotates, nothing happens. The nose of the plane didn't lift because they were too front heavy. He very sensibly increased to full power, and the rotation moment of the engines, because they dangle off the wings, actually forced the nose into the air. Incredible. A really interesting vulnerability. You can read up about it in the accident report. The plane type, Golf Uniform, Zulu, Mike, India. Really interesting to read. We've seen other instances as well from pilot error, whereby pilots calculated how much thrust they need using their electronic flight bag, what's called a performance calculator, and entered the wrong length of the runway. They departed from an intersection, so reduced amounts of distance to go. Instead, they plumbed in the whole runway length, particularly at Lisbon, owing to confusion. So the plane said, oh, you don't use as much thrust because you've got a nice long runway. And they wobbled into the air, very nearly infringed what's called the screen safety height as they took off. Happened 8 times in 2 weeks until Lisbon Airport changed their marking system. So these things happen. What else goes wrong? Getting your thrust calculations wrong can cause tail strikes, and there are probably 2 tail strikes a day around the world, partly caused by pilot mishandling, sometimes caused by pilots miscalculating the thrust calculations. And very sadly, there's been at least 1 full hull loss as a result of miscalculations in the flight bag. It's Fortunately, I suppose it was actually a freight aircraft, so there were very few people on board. But sadly, the plane, through a miscalculation, never really made it into the air and crashed with the loss of all hands. Such a shame, but evidence that things really do go wrong. This is an instance at Quito Airport in South America. Very challenging approach around hills, can be quite crosswindy, and the pilots miscalculated the amount of auto brake they needed. They didn't apply enough auto brake, and the plane overran the runway and crashed. So where am I going with this? Well, what I really want to look at, the focus of a lot of our research over the last few years, is could you make these things happen? Obviously, they happen through pilot error, but actually, could you force pilots to make these errors or force the calculations to go wrong? And that's what we spend a lot of time looking at. And going into a bit more detail about electronic flight bags. So what are they? Well, it's a tablet, it's a Windows computer, it's an Android tablet, for example. Sometimes they're physically bolted into the plane. Not so interesting to us. The ones that are much more interesting is probably the tablets that you see pilots using. So when you get board a plane, if you look left as you're going in, you'll probably see the pilots with a tablet each or a small handheld computer. And that's used to do lots and lots of interesting things. Unfortunately, though, they're not always as well locked down as they should be. And sometimes you'll see one very well-known operator. The pin is the pilot's birthday, which is easy to find out. Sometimes you find no pin at all. Sometimes you find a 1, 2, 3, 4 pin. Sometimes you find these devices given to pilots with no lockdown on. There's no mobile device management platform. And in some smaller operators, the pilot's told to go and get their own tablet, so you have no control. And often there's breakdowns as well. When cybersecurity teams try to get involved to help improve the cybersecurity, they don't always appreciate some of the problems with operating at altitude. And a good example of this, a good way to lock down a tablet would be to use biometrics, Face ID, for example, on an iPad. That doesn't work so well when you are wearing mirrored sunglasses. Try it, doesn't work very well. Pilots like wearing mirrored sunglasses because it's often very bright and sunny up there. So that doesn't work so well. And another major problem is you need your electronic flight bag for your quick reference handbook. Now, if there's an emergency, one of the first things you do, you respond from memory, then very quickly check that your actions are in line with what you're supposed to do. But to do that, you need to unlock your quick reference handbook, which is on the iPad. And if you've got a depressurization event, as you probably remember happened in the west coast of the US recently, you're probably wearing an oxygen mask as well, which doesn't make facial biometrics very useful. So there's real thought needed there. We can't just do the same things we do on the ground. These EFBs do all sorts of things. There's loads and loads of really important safety critical data on there. So let's look at some of the bugs we found. So Boeing's had a lot of heat recently. First one we found was in a Boeing platform. It's called OPT, or the onboard performance tool. It's an application that's loaded onto many flight bags for calculating your performance. So how much power you need to depart that runway safely. You don't want too much power because you're going to burn fuel and pollute the environment. But you don't want too little or you'll never make it into the air. What we discovered was a lack of database validation. There was nothing checking, verifying, validating that the data inside the database was correct. And as a result, you could tamper with runway lengths and make Heathrow look a lot longer for the calculator. So the calculator goes, hey, lovely long runway, I don't need so much power. And then you merrily tootle off the end without getting to flying speed. Now, good news was Boeing were really, really good about this. They acknowledged it well. They gave us a timeline. They kept us up to date. They published a fix, and they acknowledged it as well, which was lovely. So very, very impressive. Not every aviation manufacturer gets it quite so right. This is a semi-installed electronic flight bag in the cockpit of a 747 we were at. Breakout wasn't difficult. Passwords weren't exactly complicated. There were 2 of them, so they had redundancy, except they were networked together and you could hack one from the other, so that defeated that. And they put stickers over the USB ports, so you couldn't possibly hack them by taking the stickers off. And yeah, anyway, except airside security on planes is pretty good, but you shouldn't rely on it. If someone's motivated, it's not that hard to get around it. So bang up to date, we've given Boeing a hard time, so it's time to give Airbus a hard time. So this is a very similar product they use for calculating performance on an electronic flight bag, and basically the same vulnerability. Great. A more recent one, this is a navigational package that Airbus published through their NavBlue suite. It was vulnerable to Wi-Fi man in the middle. So you could actually genuinely do something. So if a pilot was at a hotel, you could do a man-in-the-middle attack, tamper with their database and give them the wrong data, which wasn't great. Lufthansa, not only being an airline, they also write software for other airlines and themselves too. They had an integrity problem just like the Boeing one, but they were really good. They fixed it. What you could do with this particular issue is you could tamper with the approach charts data. So as a pilot, when you're approaching a runway, you need to know your minimum safe altitude. So what can I descend to before I start my approach? So your initial fix there was at 4,600 feet, top of descent D, down to 3,900, then down to final fix, finally down to middle marker. We found you could tamper with this using the vulnerability and change all the minimum safe heights. So you could potentially bring a plane into conflict with the ground, particularly if there wasn't a precision approach like an instrument landing system, which you might be surprised to know isn't actually that common. Only the biggest airports have them. You could also do some crazy stuff as well. So you could change alerts and notifications. So you could remove the requirement to call Iran Defense Information Zone. And if you strayed into their airspace without doing so, you're going to be in a lot of trouble. Lufthansa were great. They fixed it really quickly. They've been a really good bunch. They've actually asked us out to give them a briefing next month. So I'm looking forward to going off to Frankfurt. But this isn't the end of it. So currently, many of these systems it's a separate iPad. It's a separate tablet. It's a separate computer you take home with you. What's starting to change is we're starting to see full integration of these EFBs with the flight systems. Now, this is the cockpit of an A350. Those two screens on either side, those are repeat screens that you can display the flight bag information on. Now, the flight bag in this particular case shouldn't leave the cockpit. It's actually a Lenovo laptop that's built into a docking station down by the pedestal where the throttles are. But it is removable, and it is fundamentally pretty much off-the-shelf software. Whilst Airbus are very keen that you use their lockdown version, you don't have to. You can go and get an off-the-shelf Lenovo laptop and use it as your flight bag. And that has full integration with the flight management system. So the potential for things to go a bit more wrong is a bit more significant there. But A350, amazing plane. I love it, by the way. There's also some problems with regulation. They're a bit variable all over the place, and other crazy things go on. Now, that's just a very quick review of some of the crazy things we've been looking at. We've also started looking at some of the communication systems that planes use, so ACARS, the data link, the collision avoidance systems, creating fake planes for planes to avoid, and lots of other crazy things too. Now, one of the fun things you will find in planes is you'll find a lot of very old legacy systems. And I can think of a 747, which had been flying until about a week before we got access to it. And one of the systems was running Windows NT4. 26 years out of date, which was quite funny. Took us a long time to figure out how to interface with it because all the dependencies that we don't need on modern operating systems. You'll also find crazy things like 3.5-inch floppy disks used for navigational database updates. The 737, many of the early ones still have 3.5-inch floppy data loaders, which makes things quite fun. And on one plane, we were down in the avionics bay and found a device, opened the door, and inside it was a C90 cassette. I haven't seen one of those in years. We believe it was actually playing the music as people boarded, but you do find some really odd, really old technologies at play. But anyway, hope you found it interesting. The future of connectivity in airplanes is huge. There's lots more technology arriving all the time, including we've found in the last couple of weeks some quick access recorders, which give you early access to data as an operator, so you can troubleshoot issues before they happen. With Wi-Fi access, connect via the cockpit. We've seen all sorts of really interesting things. Anyway, that's me. I hope you found it interesting. Time for a Q&A at the end, I hope, Christopher.
Yes, we will get round to that. Thank you very much, Ken. And C90 cassettes, very happy memories of my childhood. If I ever got a packet of those as one of my birthday presents, then there's nothing better. This hot topic in the next IoTSF webinar. We'll also have an OT/industrial IoT flavor, as we'll be joined by Toby Wilmington of Komodo with a presentation entitled Threats to XIoT and How Can We Secure It. If you're watching this broadcast live, you can register now. The link is in the Zoom chat facility.